Let's see a second problem based on trie data structure. So this is the medium level problem from the LeetCode, and it's saying design, add and search words in a data structure. So we need to design a data structure where we can add the word and we can search the word. So we can think that we can use a map. It's a map, we can add the word and easily we can search the word also. But there is a complexity, like in a map, if you add the word like this, you can search this word, but if you want to search the word start with B, then it's not easy to search there. We need to iterate a complete map, so that's not a very efficient way to search. So that's where we need a trie data structure. And for the trie data structure, before coming to these solutions, you must watch this video, implement a trie prefix. So first watch this video and then you can come back, you can search in YouTube, then it's a LeetCode, and then you can come to this prefix tree, just search prefix tree, and here I have explained the trie data structure. So if you have not gone through then you must go there and understand, because I have borrowed most of the code from here. Like we can say the 80% of the code I borrowed from this problem and just I added here. So in this problem there is a difference from the previous one. In the previous problem we added the word like this, but in the previous problem when we search the word, we search something start with B, but here we are searching like this B dot dot. That means any word start with B, and after that we need two characters, whether that word exists there or not. So B, here you can see BAD, after that there are two other characters, so that word exists, we can return true for this. So like this, here we can add the word and then bad return false, bad return true, dot ad return true, b dot dot return true. So that's what we need to implement. So let's see the code here. So there is nothing new from the previous code, so that's why I want to just show the code here, because there's not difference. Like 80% code is same. So exactly same like the previous video, I just created a data structure called trie node, and trie node contains two items. One is the map, and this is the end of the word. So the map contains A to G. So and like when we can add the A, some value comes, like if I want to store bad in this data structure, then I can initialize this, and inside this node I can add B as a key. So in a map I can add B as a key, and then that points to another trie node. And again, if I want to store A, then in the second node, also we have the map. So in that map, in that key, I can add this A, and the A, and then A will point to another third node, and inside that third node I can go to the map, and inside map I can add D as a key and the value another fourth node. But in a third node, because that's the end, so in a third node I can also say that okay, end of the word true. So that means that is the end of the word. So when we search that, we check that value. If you find that value, we can return true, and you can say okay, word we found the word. So that's the logic here I have added. So in this problem I filled this constructor. I also added the root node, and root node type is trie node, and here I'm returning this trie node here. So and we need we have been given two functions, add word and search. We need to implement this two functions. So let's add the word. So this code is exactly same from the previous problem. So you can check that video and then come back and you can see that code is exactly same. So let's explain a little bit. So the current node so current node is this road, so this means this has a trie node, and this is a trie node. One node we have got, and in this node we have two items. One is the map, and another is end end of the word. So that's two items is there. So we come here, and whenever we are like, when there is some word given and we want to add this word, then iterate that word. So we'll get each item, like the bad, let's say, then we'll get BAD. We check in a current node has a map. In that map, that B exists or not. So of course it will not exist in the first time, then we'll add that. So in the current node, in the map, we add that as a key. So like B as a key, and that B key points to the next node, and then we move to the current pointer to the next node. Again we'll get another character A, and then in a second node under that map we can add A as a key, and again third node that points to the third node. Come to the end like a D, and in a third node inside the third node there's a map, we can add D as a key and the value as a fourth node. But in a third node we'll also make, because for loop is done, so we make current end of the word true. So we added the one word successfully. In this way we can add all the word there in the trie data structure. You can again see this video, and we'll get better understanding over there how we are adding this letters of the word there. So next thing is search. So when we search any word, we can have a loop, and we can start with I to 0 to the end of the word, and we have done exactly the same thing in our previous video. We started with the I0 and then end like till end of the word. So that's the length of the word. So we added exactly the similar code, but in this case there is a dot. So when we see the B, we can do the normal operation, but when we see the dot, we have to do some recursive call. So for that I'm using one more variable J. But if you see the normal scenario, like in a previous video, like if you get the normal like the word like this full word BAD, so see how I'm calling this search helper and then current node. So we are starting with the current node, so we'll check first that the B exists in a current node or not, and pass the word there itself, like the word I'm searching. So the word is bad, and starting with the 0 index. So the J is nothing but 0. So I initialize J to I. So I is starting with the 0 to length of the word and I++. So exactly it's a similar in this case it will be very much similar to the previous problem where I0 less than length word. So anyway, J is 0. So if the word I, if you go to take the B, and if it is a dot, then do something. So we'll come back later, but the else portion is exactly same to the previous video. Like let's understand this first. Like when we get the B, then we'll go to the current node. Inside that there is a map, and inside that map as a key we can check that that key exists there or not. If it exists, then we can move. But if it doesn't exist, return false. There itself we can return false, but we know the B exists there. Then when the B exists, then we move the pointer to the second node, because that key the key of this map holds another second node. So we need to move to the second node. So this is current letter word I that exists there. So in a map, this is the key. So for B key we get another second node. So second node we assign to the current node. So current node is in the second place. So the loop iterate here, again I0, I become 1, then we get the A, and in the second node we can search A. Yes, we found the A. Then again move to the third node D, and again we find the D there. So that's good. For loop is done. Come outside and we check in a third node, there will be the end of the word, and that's a true. So this will return true. Then we successfully find this BAD. But in the case of B dot dot dot, so let's say let's start with from the beginning for this word. So if you get the B, so come to the else portion and we search in that node. Under the node we have the map, so we search this key, so we find the key there, and we find the key, then move to the second node. Okay, so the current node is, so we are at second node now, so current is the second node. Loop iterates, and in this word the second letter is dot. So as soon as we get the dot here, we just need to move to the next node. But currently we are at second node, but we need to move to the third node, but we do not have any key, because if you want to move to the second node or third node, and currently we are in second node and we want to move to the third node, in a second node there is a map, and in a map we need to pass the key, and if you pass the key, then only we'll get the third node, and then we can move. But we do not have that key. So in that case, what we do, the current node, that is the current node is the second node. In the second node we iterate, because that is a map, so the map has many keys over there, so we just go and iterate from there. So we'll get the value, and any value we'll get, and that is, we can say that is the whatever the value we get, that will make, that's the current node. And the front current node, we want to skip that, so that will be the next node. Automatically we'll get the next node, because this we are iterating through the map, and there is a key and the value. So the key, we do not care the key, so third node will be here, the current node, and then we pass the current node again. So now this time we are at third node, and again we search and I+1, and we move the pointer, and again we call this function recursively. Again we get the dot, again we move to the next node, and then search this, and then it will come and it will find that is the end of the word, because there's a B dot dot dot. That was, we find that because there is a some word B, and after that AD, maybe this AD, and then it can return the true. Yeah, so that's all the complete solution for this. So only thing is, this is the new piece of code here, and we are calling the recursively this function whenever we find the dot. Otherwise, the rest of the code is very much similar to the previous problem. So that's all for now. Thank you.